Hey guys. So yesterday we left off. We had just finished part A of example 9. We're gonna go and finish that up really quick. So here we go. We've been talking geometric series and the geometric series test. So the first one, part A, just a refresher, we just figured out that R was 2/7, which is less than 1, which tells us that this thing converges using geometric series test. So then we can figure out what it converges to, which is the first term divided by 1 minus that ratio. So in this case, the first term was 1 because anything to the 0 power is 1. So we get 1 over 1 minus 2/7, which gives us 7/5. Um, okay, so then we talked a little bit about some different exponent things and ways we can manipulate them. We'll get to those more in part D and E here. But anyways, let's see. The next one, part B, negative 0.05 to the n power. So if we're trying to figure out what R is for our geometric series, this is R. So the absolute value of R in this case is 0.05, which is less than 1. So that means that we can say that this thing does converge by the geometric series test. And now we need to figure out what it converges to. So the sum is going to be the first term, which again, since n is 0 here for our starting point, anything to the 0 power is 1. So 1 over 1 minus negative 0.05. And then this one, especially since it's just a decimal, we can stick it into our calculator. 1 divided by 1.05. If you want to, you can make it a fraction. It ends up being 20/21, or the decimal 0.952. Those are the same thing. The decimal does go along further than that, but that's okay. So there's part B, just another way we might see it, because we're used to seeing it as a fraction, but you could also get it as a decimal here for your R value. The next one, you want to be careful. Part C starts at n equals 5. So just, be aware of that, because if it converges, that's going to impact our answer. And we might notice whatever it is that's to the n power, that's what your R value is. So R is 1/2. So we can say absolute value of R is 1/2. 1/2 is less than 1. So this thing converges. All right, and so since this thing converges, we can find the sum, the first term. So if n equals 5 is our first value of n, then we want to figure out what that gives us here. So our first term is 2 times 1/2 to the 5th power, and then over 1 minus 1/2. And so then we can put that into our calculator as well. Let's see, 2 times 1/2 to the 5th power divided by 1/2. And we get 1/8. Or 0.125, those are the same thing. You could also do all that by hand, but a lot of times it's easier to check it in your calculator, but you should know your powers of 2. But anyways, next one. N equals 1 to infinity, 2 to the n minus 1 over 3 to the n. And we already talked about this one a little bit yesterday in this part down here when we talked about manipulating exponents a little bit. So we already broke this one down, actually. 2 to the n minus 1 over 3 to the n. If you rewrite 3 to the n as 3 times 3 to the n minus 1, And remember, we can do that because when you multiply exponents, you add the powers. If you rewrite it like that, we get 2 to the n minus 1 over 3 to the n minus 1 as a component, which means we can rewrite this whole thing as 1/3 times 2/3 to the n minus 1. So let's do that. All right. And now it looks like a geometric series. We have something raised to the n power, or n minus 1, that's okay too. And then we have something multiplied by it and all that, so we're good to go. So we can say that since r is 2/3, which is less than 1, this is convergent by the geometric series test. Great. Now we can figure out what it converges to. So the first term, if we plug in 1, we get 1 minus 1 in the exponent, which is 0. 2/3 to the 0 power is 1. 1/3 times 1 is 1/3. So our first term is 1/3. Then it's over 1 minus 2/3, which is 1/3 over 1/3, which is 1, which tells us that this series converges to 1, which is kind of fun. All right, finally, E. What we want to do here is split this up. We've got a fraction, but we've also got addition in the numerator. So what we can do is split it. We have 3 to the n over 2 to the n plus 4 over 2 to the n, which we can then rewrite as 3/2 to the n plus 4 over 2 to the n. And now we notice that this part here is a geometric series. This part is as well. It's the sum of really two geometric series, because 4 over 2 to the n is, I guess we could rewrite this one more time real quick. We have 3 over 2 to the n plus 4 times 1 over 2 to the n. So we have the sum of two geometric series here, but one of them is divergent. This one is divergent, which makes the whole thing diverge, because if this is going to infinity, if I add more stuff to it, it's just going to keep going to infinity. So this is divergent by the geometric series test because r equals 3/2, which is greater than 1. All right, so that's the rest of our examples for geometric series test. Your homework is to finish the worksheet. Have a good day, guys. Bring any questions with you to class next time, and we'll talk about them. See you later.